Good morning, guys. I hope you all are good and doing well for the preparation of your upcoming CIEs. Guys, today I'm going to solve the past paper May June 2025. Uh, that is about 9709/42. This is a paper of mechanics, and I'm going to solve this for you. Okay, let's start the question number one. It is said a crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 Newton. It means that inclined on a surface at 20 degree on horizontal surface, and suppose crate is here, right, at point A, and is going to be pushed with a force of F is 25 Newton, and that is, you can call this a driven force, which leads this crate to move from one point to another point. The crate moves a distance of 12 meter. It means if you can apply this force here, so it can cover a distance d or s, whatever you want to say, that is 12 meter upward, and it can reach some other place like B. Say it's B, and time taken to reach from A to B is given 8 seconds. And moving with a constant speed. Constant speed means acceleration is 0 meter per second square, and speed is constant. We have to find the constant speed, and we need to calculate. As we know, the particle or the crate is moving with a constant speed from point A to B, so we can use the relation between S or D is equal to V times T. So V is equal to S by T. So S is given to be 12 and T is 8. So we can calculate this on the calculator, and to give the final answer, that can be 3 by 2, or V is equal to 1.5 meter per second. This is the part A of the question 1. Now find the work done by the 25 Newton force. Now work done, we know work is equal to the dot product between force times displacement. Work is this. So if we say work done by this force and dot, once you remove this F, it will be FD cos of theta, because that surface is making angle 20 degree with the horizontal. So work done by the driven force is F is 25, and D is, we have calculated from, it covers 12 meter, and cos of theta is 20 degree. Now we can use a calculator, and our calculator, 25 times 12 times cos 20, yes, 281.9, and as a unit of work is joule, so you can write joule is the unit. Now C part, find the power at which the 25 Newton force is working. We know power is what? The work done in unit time. By definition we know this. Already we have calculated the work done in part B, that is 281.9, and time was again 8 seconds. So power will be, we can calculate it, it will be approximately 35.24 unit of is watt. Power is watt. So this is the answer. Question 1 is so simple. I hope it is clear to you. Now question number 2. Two particles P and Q of masses 0.2 kg and 0.1 kg respectively are free to move in a straight line on a smooth horizontal plane. Okay, smooth horizontal plane, no angles inclined on surface. Okay, suppose this is particle P, and here is the particle Q, and they have masses respectively 2.2 kg and 0.1 kg respectively, and free moving on a smooth horizontal. So P is projected towards Q. P is going towards here Q with its initial speed. It means U is given to be 5 meter per second. Again UP you can say, and Q with and at the same time Q is projected away from, is going away from P with the speed of, it means UQ will be 2 meter per second. Okay, as the speed of Q is less than the P, speed of p, so they will collide at certain position, and it's given when p collide with q, the particle collides. So it means when they will have a collision here, p and q, then they will collide and make a single combined mass p and q. This will be like this. It means I will add their masses, total mass become this, and they will go with the certain velocity in other direction, right? So what we have to find the kinetic energy lost during the collision. Okay, during the collision we have to find the kinetic energy loss. So it means first thing we need to calculate this v before after the impact. So here we can say law of conservation of momentum, law of conservation of linear momentum or momentum, because only linear momentum is a part of our syllabus. Angular momentum is not included for this in our syllabus. So we can say product of mass and velocity momentum. So mp up plus mq uq should equal to m1 plus m2 v, because after collision they will be equalized, so they both masses will combine to go with a certain velocity v, and we have to find v first, because loss in kinetic energy half mv square. So we need v, and let's see, m is 0.2 and it was moving with 5 meter per second, and it is 0.1 and going with speed of 2 meter per second, and here m1 plus m2, and this is we are looking for. It is 1 plus 0.2 is equal to 0.3 v. So v will be, you can calculate, it will be on calculator, v will be 1.2 divided by 0.3 gives us 4 meter per second. This is the speed when after the particle combined after the collision. Okay, now we can say law of conservation of energy, conservation of energy, that states kinetic energy lost during the collision. Kinetic energy, instead of, we can use the kinetic energy before the collision. Okay, leave this, just put the kinetic energy before collision, 1 by 2 mp up square plus 1 by 2 mq uq square. This is a total kinetic energy before collision. So it is 1 by 2, m is 0.2, and this is 5 square, half mq is 0.1, and 2 square. We can calculate this to get, it will be 2.7 joule of energy before the impact. Now total energy, any kinetic energy after the impact, kinetic energy after the impact, after the collision, that will be 1 by 2 sum of their masses m1 plus m2 v square. V already we have calculated here, that is 4. So 1 by 2 and 0.2 plus 0.1, and is 4 square, so it gives us 2.4 joule. So as we are looking for the loss of kinetic energy during collision, so loss of KE will be KE before cooling minus KE after cooling, right? So 2.7 minus 2.4, 0.3 joule is the loss of kinetic energy that has been taken place after the impact. The 4 marks question, very interesting but very easy question. We use the law of conservation of momentum to find the final velocity after the impact, v here, and then we applied the law of conservation of energy of the kinetic energy before impact and after impact, because mgh is here 0, because final and initial height is same, so that's why we used it. Okay, next question. Okay, here another interesting question. This this is given a particle p of mass is mkg, mass mkg, is attached to one end of the light insensible string of length 2.6. The other end of string is attached to the fixed point on a horizontal ceiling. Here, suppose this is A. I can change the color. Suppose this is A, P. Okay, the particle is held in equilibrium. This is very informative things which we need to underline. Force of magnitude 35 Newton. It means it's equilibrium. So leftward forces balance the rightward forces, upward forces balance the downward forces. That is 35 Newton. Acting in a vertical line which is perpendicular to the ceiling or a constant and contain the string. Okay, this is string. T, tension along the string, you can see. The force acting in the direction perpendicular to the string. In the scene diagram, the tension in the string is T, is given, and vertical distance of P from the ceiling is 2.4. Okay, it means height is 2.4. So we can resolve the first, find in order the value of M and the value of T. If we can resolve this tension along the string, here it will be T. We know we need to find this angle. Suppose this is theta. You can say theta, okay, any theta 1 or theta whatever, and this is the cos of theta 1, and here the bang will be taken place. It will be T sine of theta 1, right? Now we can resolve, we have to resolve this. The weight acts only in downward direction. The particle P, weight is W, is equal to mg and 10m. Okay, if we can resolve this component of this flying force here and here we need theta 2 as well, this angle. So it will be 35 cos of theta 2 and 35 sine of theta 2. We can resolve these forces into the components, and we have to find the angle theta. That will definitely help us to get the result. Okay, for as we know, this vertical height is 2.4. Yeah, this height is given to be 2.4, and what comes theta. So I can label A. Suppose this is B here, P here, and C here, and Q here. Suppose I labeled the figure into 2 diagrams. One diagram here, right angle triangle, and other one is here. This is another right angle triangle, right? Okay, as we have to find the mass and tension along the string, so this tension same, so I can say in triangle, right angle triangle ABP, I'm going to draw it separately for you to make more understanding about the question. I am looking for this angle theta 1. So here is 2.4 height and hypotenuse 2.6. So I can find some sine. I can use sine theta 1 some people in opposite point hypotenuse with the calculator. With the help of calculator, you can use the calculator to get what comes theta. That will be 67. Sine inverse of 2.4 divided by 2.6 give me 67.4 degree. First angle I got this. Now we know the angles, sum of angles on a line is 180 degrees. So it means angle BPC, because this is angle on the line will give me that is equal to theta 1 plus 90, because this is 90 degree, plus theta 2 will equal to 180. We have supplementary angle on the line always supplementary. So theta 2 we can find 90 minus 67.4. You can do the calculation by yourself, or directly you can write the answer. That will be 22.6 degree. I got this. Now these two angles will make my life easier. For equilibrium, I can say my rightward forces. What I can say, t cos of theta balance the 35 of cos of theta 2. This is theta 1. So t will be 35 cos of theta 2. I have 22.6 degree, and divided by cos of theta 1, 67.4. With the help of calculator, once I use it, I can get the t. That will be 84.15 Newton. You can check the calculations. Okay, fine. Approximately you can write even 84.1 Newton is fine. Best answer. Okay, now we have to find m. So other now vertical forces here. For vertical forces, in sum of Fy equal to 0. Here I equate sum of Fx equal to 0. I did. Now vertical forces, how many? The weight is going to be balanced by t sine of theta 1 plus 35 sine of theta 2. Now weight is W is equal to mg, and t we have calculated 84.1 times sine of theta 1 is 67.4 degree plus 35 sine of 22.6 degree. Value of g is 10, so m will be this whole result of right hand side divided by 10. I can find it. That gives me the answer of 9.11 kg. You can use the calculator to get this answer. I hope it is clear. Let's proceed to next question. Okay, question number 4. A car is traveling along a straight horizontal road. The car passes through point A on the road traveling at a speed of 15. Any car is coming from somewhere, we don't know, but is traveling at when it is 15 meter per second at point A, right? Not 0. Speed is 15 meter per second, and then accelerate uniformly is 0.4 meter per second for 30 seconds. So from here we need to sketch. So suppose this is A is 0.4 meter per second square, and it reach at point here. We don't know what is the speed here, v, and time taken is 30 seconds to come up at this point here, 30 seconds, right? The car then moves at a constant speed for 3t seconds. It means from here, let me change the color. It's keep moving with a constant speed for how many seconds? 3t seconds. So here it will be, the time will be 30 plus 3t, because 3t from here till here, moving with a constant speed to come at this point. And it's given where t is less than 30. Okay, this is important point, we need to underline it. The car then decelerates uniformly at 0.2, it means half of the acceleration, so it means it will go half minute, almost double of the distance will cover, half of the distance will cover, so acceleration is double, so it comes here. And after t, further t second passes through point B on the road. Say B is here and the time is here, what, t for the t second. Okay, this will be the diagram which we need to sketch, will be t graph for the motion of the car between point A and B. I did it, and I hope you got it. It's decelerate because it's come closer to the half of this initial distance from accelerating, because it is half of that acceleration. Deceleration is 0.2 minus 0.2 meter per second square. I hope you got it. Now the second part states the distance from A to B is 2750 meter. Find the value of t. Okay, as we know, distance mean the area under the graph. So a total area under the VT graph, that gives us the distance that is already given. We just need to find t. So if I can divide the whole distance in three parts, say this is the area of trapezium 1, this is the area of rectangle A2, and again area of trapezium A3, and I need to add up all, yani A1 plus A2 plus A3, that should be 2750. It is given, right? So simple is this. Required area will be, yani first A1 will be 1 by 2, sum of parallel side is 15, but we need to find what is V. Yes, we have to find first this V, because until I will not get the exact values. This is 15 here, height is 15, and what comes. Okay, as it is very much clear, the acceleration x from here, the first part A is here, I'm going to solve. A is what? Del V by t. So A is 0.4, del V is final velocity minus initial velocity, and time taken was 30. So 30 times 4 we can write is 12, is equal to V minus 15. So V is equal to 27. It means this V is 27 meter per second. So now it will make our life easy. So the difference from this point A to this point, say it's X point, that is 12. So total is 27, right? 12. So now it's easy. Sum of parallel side, one side is this is 15, right? It is 15 plus, and the other side is this one, that is up till V, that is 27. 15 plus 12, 27, and the right perpendicular distance height is 30. So I will write this. This is the A1 I calculated. So you can solve it separately, or choice is yours. On the calculator I will get it 630 unit square, or square unit, right? And A2 is a rectangle, that is the length time breadth, 3t times, that is total is 27. So 27 3 is 81t square unit, and A3 is again a trapezium. So 1 by 2 sum of parallel side, it means this is the same as B, is 15, and this is what, 27. So I can write 15 plus 27 sum of parallel sides, and height is what? This is the height in term of t, that is t. and I can calculate this. It will be 4221t. Okay, now I can apply in the rule. 6 marks question, but easy question. 630 plus 81t plus 21t equal to 2750. So 102t will give me 2120. So t will be 20.78 approximately second, and it is clear that your t must be less than 30, is less than 30. So which is less than 30, so true. This could be my answer, 20.78, or right. Now yes, it also states the car continued its journey from B. It means it's not stopped here, it needs to continue its journey from B and decelerate uniformly. It means here, if I can go back to the figure from this B point, let me change the color. Let me take the color with the green color. Okay, for C part, it states that it is going down, it is not ending here. Yeah, so it means it will comes down 0.5 meter per second, and now it's going to increase. So it means here it will, let me change the color. Why it not work? Yes, it will be here with decelerating with a is equal to minus 0.5 meter per second square and reach to at this point C. It is given it until it comes to rest on point C on the road. So if I can draw the figure separately, this was B, and after decelerating with the A 0.5 meter per second square, it approaches to rest at C, and this was 15 meter height. Already we know this. Find total distance from A to C. Okay, in the B part we have calculated, you can see the distance from A to B. Now for C we need to add this distance as well. So area under this graph, suppose this is A4. Okay, A4 will be as a right angle half base. What is base here? It is given to us this total distance base. We need to find this time. A is equal to what? V by T. This is V given 15. A is 0.5 and V is 15, and T we have to calculate. T is equal to 15 by 0.5, 30 second. 5 3s are 10 the 30 second. Okay, it means this will be take 30 seconds. So area is half base into height, that is 225 square unit. This is what I have calculated. So my total distance from A to C will be, in the first I have calculated distance from A to B plus B to C. A to B was given 2750. Yep, 2750 plus BC we have calculated 225. Now add it and we can get the distance in the calculator. You can add it. Let me do it. 2750 plus 225, yeah, approximately 2975 meter is the distance. I hope you got it. Let's proceed to next question, number 5. Yes, connected party, very interesting question. Another challenging question for most of the students, and it is, let's read the question. In such connected particles, you need to comprehend the statement very carefully because all your results will fall in between. So here it's given one end of a light inextensible string is attached to the particle A of mass 3 kg. Okay, here this one is 3 kg. The other end of the string is attached to the particle B of the mass 4 kg. Okay, mass B is 4 kg. The particle A is contact with a rough plane. It means this is the rough plane. Okay. Incline an angle 30 degree to the horizontal, and plane B is the contact with the smooth horizontal. From B onward, B is the a smooth surface, lying on smooth surface. A second light inextensible string is attached to the B. The other end of the string is attached to the particle C of the mass. Okay, there are 3 particles. Okay, the other end of the string is attached to the particle C of the mass 5 kg, which hangs vertically. The maximum weight is here. There are 2 strings. His tension is T2, say his T2. Here, this is what T1, and here it goes T1 for this case, because 2 kind of tensions T1 and T2 will be observed for the particle B, right? We need to what to do first in such cases. Read the complete detailed comprehension of the question. Both strings are taut and passes over small pulley. Here it is pulley, and you can say P. Ends of the horizontal. The part of the string from A to pulley is parallel to the line of greatest slope of the inclined plane. A, B, and C is the same vertical. A, B, and C are in the same vertical plane as shown in diagram. The system is released from rest. Okay, now it's in motion, not rest. C moves vertically downward with acceleration of this one. Neither A nor B reach the pulley. Okay, it means acceleration of C is given. So AC is what? That is what? How much? 2 meter per second. As they are attached with the string, so AC will remain same as AB, acceleration B, and B is attached with the other particles A with other string, so that is same as A, and that's all acceleration over the system is 2 meter per second square. It will remain same. I hope this point is clear because they are attached with the same with back to back, and we have to find the tensions in the string. It means T1 and T2 we have to calculate. So first of all, starting from particle C, because that is the most heaviest particle, which because of which the motion is possible. So we know that driven force minus resistive force is equal to net force. We know this because when the system is released from rest, we need to keep this mind. At C, driven force is what? Weight of C, and resistive force is tension T2 only, and net force is MC and AC. So weight is what? C has 5 kg, so WMG it will be 50 minus T2 is equal to 5 and age is 10. So T2 will be you can calculate it. T2 50 minus 10 is 40 Newton. This is the tension on the string which is attached with B and C. Okay, I hope it is clear. Now if we can go for particle B, for B, on B we know the driven force minus resistive force is equal to net force, as because B is also moving. So driven force is what on B? That is T2, and resistive force is T1. You can see here because this is T2 and this is T1 going in opposite direction, and net force is MBAB, as here I already have mentioned this. So T2 is 40 minus T1 is equal to, what is the mass of B? That is given 4 kg, 4, and this is 2 of acceleration. T1 will be 30, 40 minus 8 is 32 Newton. This is easy question, but if you go with the statements, big statement, but the answers and the solution working is very little. Okay, this part A we have done. Now find the coefficient of friction between the A and the inclined plane. Okay, now go back, and here as the particle A is going up, so and surface is not smooth, so it means resistive force will be here, and we can resolve the weight component of particle A. That will be W sine 30 here and W cos 30 here. Okay, now we will observe for particle A, for A, and we have to find the what let me do in part B. Coefficient, that is 4 marks for A part here. So here driven force minus resistive force is equal to net force. Here you can see the driven force on A is tension because going up, and two resistive forces mu r and W sine 30 applying going in opposite direction of the driven force. Okay, I can say T1 driven force minus mu r minus W sine 30 is equal to M A and AC AA, because AC AB acceleration is same, and so we have to calculate coefficient mu. So R is what? R is this W cos theta, weight component of W cos theta balanced by R. So we can say R is equal to W cos of 30 degree. So T1 already we have calculated. Now I'm going to substitute the values. So let me change the color. As this is 40. No, 31 is 32, sorry. Minus mu we are looking for, and R is what? W is A particle has mass what? 3 tens are 30. Cos of 30 degree minus 30 sine of 30 degree is equal to 3 times, and A is 2. So here we can just simplify and get the calculation on the calculator to get the marks, but be careful about your calculations. So 32, I can write this mu 30 cos of 30 degree equal to, and shifting the rest on other side, is 32 minus 6 minus 30 sine of 30 degree, and mu will be calculated as, you can do the simplification on calculator. I'm doing it directly. It will be 11 over 15 root 3 or 0.423. This will be the final answer for this part B, 4 marks. I hope it is clear. Now still we have to go for the D. Okay, in C parts given when the system has been in motion for 1.5 seconds, the string attached to A breaks. Okay, so it will come down with the force of gravity. Yeah, the total distance that A travels up the plane from the instant that the system is released from rest to the instant when it comes to the instantaneous rest. Yani it mean it goes here, the distance from here to any A to this, near the pulley, this is pulley, and then again back to down. We need to calculate this distance before it breaks and after breaks. Okay, So the system has been in motion for time total taken is 1.5 second. Okay, here given t is 1.5 second, and we know we need to find distance, how much it goes from this point A till this point, say K, L point, right, from A till certain point before the pulley. It was already mentioned in the question that they will not reach the pulley. And starting from rest, so 0 meter per second. I'm just writing the information which help. And acceleration, already we know that a b and ac was a, that is 2 meter per second square, it was given. So let's see how much distance covered until string break. So distance covered while going or moving up, that is s. We can say s is equal to ut plus half at square. I can use this Sweat equation. So s will be u is what, 0, t is 1.5, half a is 2, and t is 1.5 square. So I can say s for the first going up is, on the calculator, 2.25 meter is the distance which it can travel up. Now we find the speed with which it moves, comes down. Okay, so final speed with which it goes there. Now we will find the speed with which a moves up. This is final speed, huh? Say it's v. So v is equal to u plus at. At this point, what will be v? U is 0, a is 2, and t is 1.5. So it comes to be 3 meter per second with which it reached at the point L, right? V at L, at point this L, we can say it's L point is here with this speed. Okay, now when string breaks, I can make the partition, yes, change the color. When string breaks, it means there will be no any other tension along the string. So it means driven force equal to the resistive force, and it goes speed any, I can say the net force will be minus any w sine theta minus mu r, because driven force, resistive force equal to then they will be equal. So here I can say F will be force with which it comes down. Resistive force, that is w is what,